I also feel like a rock star, at least inside. I don't know how to play any instrument, but let's hope I can give you a good presentation at least. So, once upon a time, critical manufacturing built a great product. And this is one in a million. It's very hard for any company to build a successful product. But we didn't stop there. We built another great product, which was Connect IoT. So we built an application that is able to connect with an interface with everything in our shop floor and in the real world. But we weren't content with that. We wanted to go even further. So we released IoT Data Platform. And this talk is exactly about that. It's about merging what the MES gives us, what Connect IoT enables, and what Data Platform shows. Okay, so this is kind of the main topic of this session. So this is our agenda. First, we are going to understand the difference between data and information. So this is a critical difference. We are going to understand how the MES contextualizes information. Then we are going to see how can we interface with the real world, so gather this data. How can we ingest it, and then how we can show it. How can we be transparent about data? So how can we bring data from the shop floor into real actionable information? So this is a nice picture, I think, because it showcases that there are actually two worlds. There's the actual world, and then there's this kind of virtual world. So we can see in the left side that in the real world, everything is messy. Things are happening. It's chaos. We have different sensors, different operators, different systems. So how can we bring this chaos into order? So this is where the MES acts as a big contextualizer. So the MES is the key application that not just watches over your shop floor, but actually understands what is happening, actually contextualizes what is happening. But let's take a look further inside the MES. So how can the MES achieve this role as a contextualizer, and how can it interface with reality? This is where IoT comes into play. So Connect IoT is really the interpreter of reality. It's the one that is responsible to interface with machines, interface with sensors, bring everything together, and then contextualize the data, because it has a noble approach with MES. It has a key integration with MES. So it's able to leverage MES to enrich the information that it's receiving from the shop floor. And then we go into analytics, dashboards, all the cool stuff that everyone wants to see in the end, because that's what enables decisions. So takeaways from this. Reality is messy. It's very hard to turn data into information. The MES is able to contextualize reality. It has a vision upon reality. MES is opinionated about reality. It knows that you have sites, areas, facilities, resources. It knows that you have products, flows, steps. So all of that model is an opinionated and contextualized approach to reality. And then we can have Connect IoT being this interface to reality, this interpreter of what's happening in the actual shop floor. So this is the roadmap for today. We are going to start with a use case of SMT line. So we will have to build our model. So we have to build our opinionated context of reality. We will have materials, we will have resources. We will have Connect IoT interfacing with an equipment. Then we will move on to the next layer. We are going to do some data ingestion and then perform some analytics and dashboards on top of that. So this is our flow. We kept it simple. If anyone has worked in SMT knows that SMT is super simple, except when it's not. So typically people say that in the SMT line, stuff comes in, stuff goes out. So it's a very straightforward transformation process. Of course, if everyone works there, it knows that actually a lot of stuff can happen inside the SMT line. So I chose a simple flow. We can have here, we have an order preparation, we have serialization of PCBs, and then we have our SMT line. But what is happening there? So actually, in terms of materials in the MES, what is happening? So we are creating a production order. We are creating lots. Our lots have panels. So this is kind of what we are working in the shop floor. This is how we model what's happening in the shop floor. We saw Walker Reynolds in the big stage talking a lot about unified namespace and a lot of different approaches about how can we gather information or data and turn it into some kind of dashboards, analytics, real-time transparency on data. But, and this is my personal opinion, I don't want to grab Ricardo into this, but my personal opinion is that analytics is great, it's awesome, it allows us to make decisions, but we need to actualize those decisions. So this is where also Connect IoT shines, because Connect IoT enables us to have actual control. So if your equipment is able to have an interface for control, we can gather all this information, all this context that MES has, and not just show a dashboard, but actually perform actions, actually stop the machine, actually allow or not allow a material to be transformed, sending recipes, are the recipes okay or not? So all of this control world that was actually a bit where MES was born can be enriched by data, but we don't want to lose this control aspect, which I think it's very important. And it's actually one of the most fascinating things about how a shop floor operates in the real world. So Connect IoT supports a lot of protocols. Some of these are standards in the industries, others are more segment-oriented. So for our use case, we are going to see IPCC-FX. IPCC-FX is mainly used on SMT. And I just want to stop here a moment to say we chose the IPCC-FX because it's an interesting standard, and I'm going to explain a bit further ahead. But just so you have in mind that it's not that important you know all of these and work with all of these, or that we even support all protocols that exist in reality, okay? So we have a framework in order for you to build on top of this, and we'll showcase that a bit more later. So why they chose IPCC-FX? I don't know if anyone has ever heard of IPCC-FX. It's kind of an up-and-comer, fairly new standard, but it's interesting. Why? Because it merges this idea of big data, of having brokered communication, so someone is emitting to the broker, and then we don't even know what clients exist that are connected to that broker and gather information from machine events. But then it also allows that with control. So it allows for peer-to-peer request response with machines. So you are able to have that analytics, unified namespace, dashboards, and everything else, but you are also able to actually perform control in machines. And then it's one thing that we love, which is strong type standards. So there's no dynamism here. We know beforehand what are the messages, how they behave, when they appear. So it's a very easy to map protocol. So basically, this is what we are going to do today, and what I'm going to showcase. We have a reflow oven. We have a broker. In this case, I'm showing RabbitMQ. There are other types of brokers. We have Connect IoT interfacing with a reflow oven. So a reflow oven is a part of the SMT process. Okay. Then MES will gather information from Connect IoT, and some part of this information is transactional control information, like a material has come in, can a material go in? And another part is analytics, is the oven has produced this material, and in each zone it has a set of parameters that we want to collect. So we can ally both parts of this world. So this is also an interesting point when we are dealing with automation, and this is why I think most people think automation is very complex. Because most people don't want to read the manual, okay? So most people want to go right in and start working and then don't read the specification. This is where Connect IoT helps a lot, okay? So Connect IoT serves as not a replacement of going to see the manual of the standard that you are using, but it already helps you a lot in having things created beforehand for you. So, and actually, just to say that the information from IPCC-FX, where you can go to their website, is actually quite good. The UI may be a bit boring, but it's interesting information. And so here at Critical Manufacturing, what we do is we analyze these standards, we understand how they work, and then we build a framework to help you. So in this example, as I was saying, we have two big groups of actions. We have material tracking, so we want to say that the material has come in the oven and has gone out, and then we want to capture some process data. So this is where I was saying about seeing the standard. So the standard says that when the material goes in, you are doing a work started. So a work started is an event in IPCC-FX. The machine will say, I have started producing. And you have all of this information. But it's a bit cumbersome. So if you see this, if you see the work completed, you can see that there's a lot of different details that are extensively specified in the standard. For units processed, which is our analytics event, it's even worse. You can see that there's even more information. So this becomes a bit of a pain to try and understand all of this and try to map it. That's why we have Connect IoT. So Connect IoT is a local framework interface. So it's a local framework to be able to build business logic to interface with external systems, as I was saying. And you can see here our designer. So keep in mind what I showed before. This is solved here. So here is an event called work started. And everything that's inside works in the context of that work started. So what we see here is this integration. I am saying that whenever I receive a work started, I want to store my transaction ID. So this is the context of that message. I want to retrieve whatever MES entity that I have running for this automation, because that's contextual information that I need for enrichment. Then I'm going to perform an MES action. I'm going to perform a track-in. For my work completed, you can see that it's analogous. It's exactly the same. I have a work completed. In this case, I'm going to do here some cleanup, and I'm going to perform a track-out. Now, for my analytics event, you can see that it's a bit different, but it follows the same structure. You have a units processed event, so you are responding to events. The machine is sending events, and you are doing actions. You are retrieving the transaction ID, retrieving the instance entity. Why? Because you are enriching what you want to send to data platform. So basically what I'm doing here is I'm grabbing the units processed event, and I'm going to send the post event to my data platform. Okay? So it's as easy as this to create an integration with a reflow oven. But also, CFX is used by all SMT machines. So probably they have analogous events to do just this for pick and place, printers, AOIs, wherever you can think that's inside an SMT line. Of course, not everything is an SMT line, and if you're talking about other segments, they may have a more, how can I say this, United Nations type of vendors with different protocols and different things happening here, but Connect IoT serves exactly to abstract that complexity. So the best way to showcase this, and we are in the tech track, so we want to show actual things happening, is building a demo. So that's what we did for today. Our demo basically is we retrieved information from a lot of reflow ovens. So we understood how reflow ovens actually work, what kind of events they actually produce. We compare that against the IPCFX norm. And then we create a simulation where we create synthetic data based on the data that we gathered from reality. So we gather that data, we send it to Connect IoT and to the MES, and we have a running simulation of SMT machine. So right now in my computer, I have running an SMT line, a virtual SMT line connected to an MES system. So this is more because we are in a tech track, as I was saying. So some information on this. Basically what I did was I built a .NET app that has a CFX handler. I have a broker inside of my app, and basically this is how my simulation is continuously running. This is interesting because what I did was, and this is a bit more tech-wise, but as we said, we are in the tech track, so let's not be afraid of going a bit technical. Critical manufacturing gives us or provides tooling to build tests. So we already provide a framework for building tests, and what I did was I went to my framework, I grabbed the IPCCFX nuggets, and I create my .NET application. So this is also something that we offer. We offer not just a tool to be able to integrate, but also tools to be able to test, which I think is interesting. So what about the data part? So we are talking about Connect IoT, about the MES. What about the data part? So what is happening is that we are gathering information from the MES, so like what we call material movements, so track-ins, track-outs. And we are also gathering my units process, so my oven information. We are sending everything to Kafka and to ClickHouse then, and we will have an application called Data Manager where we are able to pull that information and create, either in this case, Grafana dashboards, as we will showcase, but Power BI and so on and so forth. So let me showcase a bit of my demo, so you believe me and see that this actually works. And so
São mais 2, 3.
Let me change my
A
screen to
seguir vem
duplicate,
sozinho
maybe.
e depois aqui são mais 2. Olha, tira-me lá aqui uma foto. Que aquele senhor não,
Okay, let's keep
não
it like
tira
this.
fotos nenhumas.
So basically, what I was saying was
Tá?
that I built here a .NET application that you can see it's
Boa.
running and it's creating events, so and creating payloads. And
Tá
now
espetacular.
I can go to my observability.
Ai pá, eu tinha era esta porcaria, parece que estou toda brilhante.
Let me.
E ele estava no modo
Can you see it?
Yeah.
Okay, so it's very important. It's a bit of a side note and a tangent, and you're going to have a presentation by Giuseppe Silva in a moment regarding this. But basically, with observability, we can have Connect IoT running somewhere on edge and be able to collect information. So right here, what I can say is, I'm going to have, I just have one environment, but I could have several. So I'm going to see my IPCCFX manager.
Está ótimo, está fixe, está fixe.
And you can see that a lot of stuff happened here. So I have lots of messages. And I can see, for example, that I'm posting a telemetry events. So let me see if I can grab the MES. You know, I chose this way of presenting just to be even harder for me. So this is Connect IoT. So we can see here that what I did, I wasn't lying. So I have here my work started, work completed, my units processed. And I think maybe, Ricardo, we can go to,
Yep.
to the data parts. Vamos fechar isto.
Isto é muito difícil. Não consigo só mapear, acho que posso experimentar uma coisa.
Vamos só para esta assim. Okay, so I think everyone understood how this was happening behind the scenes, at least for a bit. I think you believe me. And I think Ricardo can show how we can create this, or how can we grab this Connect IoT integration with the reflow oven, and what we can showcase data-wise. Ricardo, it's your time to shine.
Yes, let's see.
You are the rock star.
Let me try to duplicate the screen. That's it.
Então ele deixa
So,
cortar.
like João was saying, where's the MES? Ah, okay. Okay, so like João was saying, we are in fact collecting a lot of data on the equipment. And one of the most difficult tasks to do is when we are collecting data at the equipment, and we must correlate them with the actual data that MES is producing. This comes with multiple difficulties, mostly regarding timestamps, because the equipment has different timestamps than the MES has, or it shouldn't have, but it has in practice. And in the same time, we are collecting really a lot of data from the equipment. From this SMT line, for example, from the reflow oven, we are collecting a lot of parameters that are being produced when a specific panel exits the oven. So what we've done is basically create, like João was saying, create a dashboard that in fact does exactly that. So it correlates not only data that is coming from the MES, but also data that is coming from Connect IoT. And basically that's the dashboard that we ended up doing. One of the most difficult, or one of the most tricky parts of an SMT line is to have, or at least in the reflow oven, is to have a controlled reflow temperature. So that line that you see here is the profile of the temperature that you need to heat up all the panels so that the reflow actually happens, so that you need to make the flux exit from the solder paste. So we had to have this kind of control, we had to have this very strict control on the temperature. And basically what we are doing is receiving the data from the equipment, and an interesting fact is that the equipment only knows the lot number or the panel number. And that's exactly what we did. So we are receiving the panel number, and if you remember, João is also doing the track-ins and the track-outs and the create lots in the MES. So we have two streams of data coming at the same time. And what we've done is, using IoT data platform, we are able to not only correlate the lot number, but also the parent lot number, and by that, correlating also the products. And that information is what we are showing here. So we have panels leaving the SMT line, or in this case, leaving the oven. You have here exactly points that we are collecting so that we can track the curves. These are all the products that we have been producing during this demo. And if we go down a bit on the dashboard, we also have the deltas. So we have here what is the set point of the temperature, and this oven is behaving, or at least it's behaving correctly, and those here are the deltas between what is exactly the set point of that specific point in the reflow oven and what is exactly what is Connect IoT and what is the simulation saying us. So it's very important to have the control, or the exact control, and at least a visualization, so that, for example, this point over here, we have a 20 degrees delta that might have, or we might, for example, pop a component because the component is moisture sensitive, for example, and if we heat up very quickly, all the water there vaporizes and pops the component. It's one of the most typical processes in the oven. Then on the other part, we have over here what are the materials that are exiting the oven, and then we can simply click on the material and we show all the data that we have been collecting for that specific panel using IPC-CFX. So you see here multiple parameters that we are collecting. So we are collecting O2, power level, temperature, and vacuum hold time. Of course, we can correlate them, and like I said, we are seeing a specific value for this panel, and basically we can show you also down there what is that history of that panel along the SMT line. So you see that it was expanded from the main materials, or from the panel material, the parent material, sorry. We later went to serialization, we went to a printer, then solder paste inspection, then 3 layers of pick and places, and then finally this SMT oven and the optical inspection. So basically we are collecting all this data not only in the MES, we are collecting this data not only in Connect IoT, but most importantly we are correlating these two worlds, and that is one of the major tasks that Connect IoT together with the CM MES and also data platform are providing in this dashboard. And it finalizes our presentation for today.
Yeah, I just want to show something, which is you have this incredible dashboard that Ricardo built. But actually, this all came from events that were being generated. And so we can see here, actually, that I was sending post-telemetry events. And here, it's all the information that it has to be kind of constructed in order to create our dashboards. So basically what we did was we correlate these post-telemetry events with also MES-generated events. So if I go here to material movements, we can see here that actually what's happening is that we are generating material movements events for everything that's happening in the MES, and then we are cross-relating them with all the events that were generated by the machine. So of course we built this dashboard, but there's nothing stopping you from grabbing that information and creating other types of dashboards. So basically that was just my small side note.
Great.